Okay, this is my first video build vlog of the ORX214G. Named so because it's using two S107 power plants at the front and rear, which makes 214 from 107. ORX stands for the Orange RX, which I'll be using, DSM2 compatible with the E-Flight remote. The G because it will have a gyro once it's finished. That's this Vtail unit here, as you can see in the gyro test video, which is coming up in a second. Here's a simple diagram I drew of the setup. On the diagram I've drawn the yaw control going to the rudder. It'll be going to the aileron, so it's set up like a 3-channel controller. So we have as the throttle comes out, goes into the elevator for the PMS, which is the primary mixer. So what that would do is give equal signal to both ends of the craft, giving equal lift. Then the elevator goes into the aileron, which varies more to one servo and less to the other, so that'll give the balance of forward and backward to these two mixers. Both these mixers are fed the throttle into the aileron to give both motors equal signal, and the aileron is plugged into the rudder via the gyro, so this will vary the balance between the top and lower set of rotors, which gives it the yaw control that we're used to with coax helicopters. And imagine the first thing you're wondering is, why has this Chinook got legs? Well, basically what I'm aiming at here is testing the link up between 3 Vtail mixers. That's FA, so this is the mixer for the front, which controls the balance of the upper and lower rotors for the front yaw. This one, the same for the rear. Then back here, one of these two, which is unlabeled at the moment, is the main mixer. So it takes the throttle input, gives equal outputs to both these mixers. Then the yaw would be hit with a Y splitter to give the yaw signal equally to the other half of each of these mixers. I don't have a Y splitter at the moment, so I've hooked in a second, well, actually a fourth mixer, which is just acting as a passive Y splitter for the test. The reason it's on legs, these servos didn't come with horns. They're drinking straws, and the reason they're on legs, I say, is to test the link up. Let's fire it up and show you what it's doing. Plugged in and connected, so just before I start moving the sticks and explain what the actions that you'll see are. So with this, when the nose is down at the front, that's forward pitch is going forwards, tail down, rear pitch. Banking starboard, which will be towards the camera, is starboard yaw, and the same for port. So first, let's throttle up. Let's put it to about 50% throttle. I set the controller up as 3-channel like you'd find with the S107, just to keep it easy for me to understand at start. So your forward pitch, no, less power to the front, more power to the rear, nose goes down. Rear pitch, same in reverse. So we're going to turn right, which is yaw, so we'll bank towards the camera. And bank left, which is left yaw, away from the camera. Hold down, back up, forwards, backwards, right, left. Now, these stalks and the servos, these all 4 servos are identical, so I'm basically going to take the circuit boards out of them, give them the constant rotation modification. There'll be single direction, which will be done by shorting between the centre and 1 signal half from the potential resistor where that connects to the circuit board, and adding the full value of that variable resistor between the centre and the other pin. Stay tuned, I'll have more when I've got time.